All right, we're continuing on with ChemQuest 32. I already have the video that shows that percent yield is actual yield divided by theoretical yield times 100%. And then we went over these questions in that first video. Yesterday in class, or I should say Monday, the 6th of June, we talked about these three problems. And if you want to pause the video right now to check your answers, to make sure that you have all of the work, that you show things here. I'm going to show these things dividing out so that we get units. It's really important that our units divide out. And so these are our percent yields on these problems. I began doing this a few moments ago and I had a phone call, so I ended up working part of this problem without you. First thing I did on this problem, and it says I have 297 grams of zinc chloride that was produced. So this is my actual yield. Sometimes they give you the actual yield number first. It was a single replacement reaction of excess zinc and 202.7 grams of lithium chloride. So I know that zinc and lithium chloride are my reactants. And I already showed how we figure that out. It turns out that lithium and chloride are 1 plus and 1 minus, so it's a 1-to-1 ratio. Zinc is always 2 plus, chloride is always 1 minus, so it's ZnCl2. And because of this, I knew I had to have 2 lithiums, or 2 lithium chlorides, and then I have to have 2. Now, I'm given 202.7 grams of lithium chloride is what I started out with. I then looked up the molar mass of lithium chloride. I know that lithium is 6.94 and chlorine is 35.45. When I add those together, I get 42.39. And I already did that part. I know that my mole ratio of zinc chloride to lithium chloride is 1 to 2. And I calculated the molar mass of zinc chloride because I know zinc is 65.39 and chlorine is 35.45, and I have 2 of those, so I multiplied that by 2, added the 65.39, and I got 136.29. So in order to figure out the theoretical yield of zinc chloride, I take 202.7 times it by 136.29. divided by 42.39, divided by 2, and I get 325.85. All right, now when I did that, notice that I only have 3 significant figures in my actual yield, so I'm going to round that to 326. And then I'm going to put my theoretical yield here, 326. Now, if you get a number that's not close to 297, and it probably means you made a mistake. Now if I take 297, which is my actual yield, my experimental yield, divided by my theoretical yield, which is my calculation, times it by 100%, I get to 3 significant figures, 91.1%. And again, I'm doing 3 significant figures because there's only 3 significant figures here. The next problem, it says I have calcium chloride, and they already have the formula. That's nice. It reacts with silver nitrate, and they give me the formula. Again, that's really nice. It produces 21.5 grams of calcium nitrate, so that is going to be my actual, for my actual yield. And they tell me the formula, which again is really nice. And it says, okay, so I did have to figure out if this is a double replacement, I know that it's going to be silver chloride. So I did have to figure this part out. Silver chloride is AgCl. Before I do anything, I have to balance this. I see that I have 2 chlorines here, so I can only change coefficient, so I have to have a 2 here. And then I have 2 nitrates, so I have to have 2 here. And I have 2 silvers. Remember, whenever you have a polyatomic ion like nitrate, you treat it, sometimes it helps put parentheses. So it appears to be balanced. 1 calcium, 2 chlorines, 2 silvers, and 2 nitrates. We're good. 24.5 grams of calcium chloride Again, we know calcium is 40.08 and chlorine is 35.45. And so when I times that by 2 and then add the 40.08, I get 110.98 grams of calcium chloride per mole. Again, I'm dividing by the molar mass. Now I have to times it by the mole ratio because I want to know how much calcium nitrate is produced. And so the mole ratio of calcium nitrate to calcium chloride is 1:1. That's always really nice when there's a 1:1 ratio, but even you still have to make sure you show that. You can't skip that step because we have to show moles of calcium chloride dividing out. Now we have calcium nitrate. Again, we know calcium is 40.08. I have 2 nitrogens and I have 6 oxygens. When I add those together, I get 164.1 grams per mole. The moles divide out, and I have grams of calcium nitrate. When I put all of that in the calculator, I get 36.2 to 3 significant figures. I really only need 3 significant figures because both of these values are only 3 significant figures. I'm going to then bring my theoretical yield over here. I've already put my actual yield was 21.5. My theoretical yield was 36.2. Again, if these numbers are way off, like this was 362 or that was 215, then I probably have to check to see if I made a mistake. 21.5 divided by 36.2, I get 59.4% yield, which is not a very good percent yield necessarily. Okay, this is 91.1. Okay. Problem 3 says I have aluminum sulfate plus magnesium, and I know magnesium is Mg. It's really nice that they gave me the formula for aluminum sulfate. I know aluminum's 3 plus and sulfate's 2 minus. It says what is the percent yield when this much aluminum is formed? So if aluminum is formed, it's clearly going to be a single replacement reaction. I know that magnesium sulfate is my other product. Magnesium's 2 plus, sulfate's 2 minus. Before we go anywhere, we've got to balance this. I see 2 aluminums, so I'm going to put a 2 in front of aluminum. Again, you can't change subscripts. You can only change coefficients. And then I have 3 sulfates, so I need 3 sulfates, if it helps to put parentheses around the sulfate as you're balancing. And then I'm going to need 3 magnesiums. So I have 2 aluminums, 3 sulfates, and 3 magnesiums, so that's balanced. I'm given 312 grams, 0.7 grams of aluminum sulfate. I now need to figure out the molar mass of aluminum sulfate. Well, I'm going to have 2 aluminums, so that's 2 times 26.98. I have 3 sulfurs, so that's 3 times 32.07. And I have 12 oxygens. Do you see that? 3 times 4. Oxygen 16, 12 times 16. Doing the math, make sure you know how to do that and you're not on the actual test. 342.17. All right. And so that's going to divide out. Because I want to know moles, I have to do mole ratio. There are 2 moles of aluminum for every 1 mole of aluminum sulfate, so that's 2:1 ratio, mole ratio. I now need to multiply by the molar mass of aluminum, which is 26.98. So when I take 312.7 times 2 times 26.98 divided by 342.17, I get 49.31 grams of aluminum. That's my theoretical yield that goes on the bottom. My actual yield given in the problem was 38.5. When I divide those and I times them by 78.1%, divide them by 49.3, times it by 100%, I get 78.1%. All right. Just in case you need to pause, that's the, okay. Problem 4 Again, if you need to pause at any time in the video, rewind, that might be helpful. It says, consider the reaction in which 370 grams of calcium nitrate react with just the right amount of lithium. So we know calcium nitrate is reacting with lithium. And they gave me the formula for calcium nitrate, which is kind of nice. In fact, you see that we figured out the molar mass of calcium nitrate over here, 164.1. I already did it, so I'm just going to put that here. I already know that from this problem. See that? So sometimes you recognize that. And lithium, okay, it reacts with lithium to form lithium nitrate and calcium. And I know it forms lithium nitrate because that's what we're trying to find. And because it was a single replacement reaction, calcium is left out. Now, is this balanced? I see 2 nitrates. I need 2 over here. I now have 2 lithiums. I need 2 lithiums. And it looks balanced. Okay. Now, I have 370 grams. This was given in the problem. And again, I got this 164 because I looked at the previous page because I already did the math. You don't have to do it twice. I now need to know my mole ratio of lithium nitrate is 2, and calcium nitrate, that's an understood 1. My mole ratio is 2 to 1. And now I get my grams of calcium nitrate divided out, my moles of calcium nitrate divided out, and now I want my moles of lithium nitrate to divide out. Lithium nitrate, again, lithium is 1 plus, nitrate's 1 minus, that's why I knew it was a 1-to-1 ratio, 6.94 plus 1 nitrogen, which is 14.01, plus 3 oxygens, which are 16 each. When I do the math, I get 68.95 grams. So when I take 370 times 2 times 68.95 divided by 164.1, I get 311 grams of lithium nitrate. That is my theoretical yield. All right. Now this problem actually is a little different. It says that my percent yield is 74.3%. All right. I don't know what my actual yield is, so I have to figure that out. So if X was my actual yield, I would say actual yield divided by theoretical yield times 100% gives me this. All right. So if I times both sides by the theoretical yield, I know that X is essentially going to be my percent yield times my actual. So this is my percent yield times my theoretical yield will give me my actual yield. So if I take 74.3%, which is in decimal form 0.743, and I times it by 311, I get approximately 230 grams of lithium nitrate. And some people would argue that because they told me 370 grams here, there's only technically 2 significant figures. All right, question 5. It says I have 42.4 grams of aluminum that react with excess oxygen. And look at, they gave me the balanced chemical equation. How nice. I get 67.3 grams produced. This is my actual yield. All right. And so I know that my percent yield is going to be my actual yield. Remember, 67.3 grams of aluminum oxide. That's also called bauxite. And I have to divide that by my theoretical yield. So let's figure out what the theoretical yield is. I have 42.4 grams of aluminum. That's what I start with. And in reality, they usually go the other way around, where they're actually trying to get aluminum out of aluminum oxide. So 42.4 grams of aluminum divided by the molar mass of aluminum. By now, you should know that aluminum is approximately 26.98 grams per mole. My mole ratio is 2 to 4. They gave me those coefficients. They gave me a balanced chemical equation. That was very nice of them. You can leave that 2 to 4, or I could simplify that as 1 to 2. You don't have to. My molar mass of aluminum oxide, I would take 2 times that 26.98 plus 3 times 16, and I get 101.96 grams per mole. When I multiply 42.4, you might be multiplying by 2, times 101.96, divide by 26.98. You're either dividing by 4 if you didn't simplify this, or divided by 2 if you didn't. You would get 80.12 grams of aluminum oxide. We'll put this over here. 80.12 grams of aluminum oxide is my theoretical yield. This is my laboratory yield. Times that by 100%. Okay. My percent yield is approximately 84.0%. All right. So there you go.